Well, since the International Space Station's Expedition 2, some 11 years ago, actually, and before that, on shuttle missions dating back to 1996, there have been middle school and college students that have gotten a chance to participate in spaceflight by taking pictures from orbit. The program is called Earth Knowledge Acquired by Middle School Students, and that translates in NASA into EarthKAM. It was developed by former astronaut Sally Ride, and the project is still administered by her science education company, Sally Ride Science. EarthKAM is in operation on board the International Space Station this week, Earth Week. We've decided to get students more involved in the current mission. They even have a special challenge that we're going to learn about this week from Brian Awe, the EarthKAM payload developer. Brian, welcome back. EarthKAM, just to get this straight, EarthKAM doesn't operate continuously on board the station, does it?
No, it doesn't. It does not. It's set up for a week-long mission. They call them missions, and we do that 5 times a year. We'll set up around the end of January, again in April for the spring mission. We'll run in July for the summer mission. Again in the end of September, beginning of October, and then another mission in November. So it'll give the teachers and folks that want to participate a chance to get into one of the 5, if not all, of those sessions for that week.
And you can click that and it'll hold its position, so you don't have to hold it there. Now, EarthKAM right now is set up inside Node 2. It's usually Node 1, right?
That's actually
usually
WARF,
the lab.
In the U.S. lab, in the Window Observational Research Facility, or WARF as we call it, because there's a larger payload in there right now. It's a huge telescope called iServe. We have an alternate location in Node 2, and that's where we're set up for this week.
Now, we've talked about this enough to know that people are taking pictures, but I asked you specifically, what kind of camera are they using? What kind of camera is up there taking pictures?
It's actually a digital still camera. This is
not
a
so
Nikon
unusual.
D2XS. No, it's a commercial off-the-shelf product. We have several on board, and the only thing unique about the whole EarthKAM system is the suite of software that we run on a laptop that's tethered to the camera by a USB cable, and that allows us to command the camera to take the picture, and then it automatically downloads that image from the camera to the laptop, so we can bring them down to the ground and get them posted for the students to see.
Now, let me take you back a step further and talk about how the students are involved. Give me the thumbnail sketch of how kids are taking pictures from space.
Okay. What we do is take an orbit track of the space station. We know where it's going to be flying overhead, and we superimpose that orbit track on Google Maps so that the kids can literally zoom into the target that they're trying to acquire. And what that does is return data so that they can fill out an image request. And if the image is within the footprint of the camera as it flies overhead, the software will check that and accept the image. If it's outside that footprint, it will reject it. And that puts together a camera control file that we uplink to the camera. It's a series of time hacks. When the station's crossing over that point on the Earth, the software tells the camera to take a picture, and it will at that instant. And the image process just flows the image to that laptop so we can get it on the ground.
These are middle school students who are doing this work and figuring out what target they want to shoot.
Yes, there is geometry and physics and the whole suite of mathematics and types of activities involved in actually acquiring an image. Yes.
They're figuring out the target, but then they're just the first step in a process then to get that camera control file on board.
Yes, yes. That process works out at the University of California at San Diego. There's a team of undergrad students who will receive all these image requests from the students around the world. Currently, we have 411 schools, over 29,000 students signed up to participate in this mission. This week, yes. That number is almost double what we did in our February mission, which is significantly higher than we've seen in the past. So EarthKAM is starting to get the exposure and the use that we're trying to build.
And we were talking about there's a mission control in San Diego.
We call it the MOC, yes, the
Hmm.
Mission Operations Center. The undergrad students out at the University of California at San Diego staff this MOC, and they bring in the image requests, process it down into that camera control file, send it to us here at UCSD. They put it on our server. They have access to it, and then I will error check that, virus check it, and then hand it off to the OCA operators, who in turn can uplink it to the station.
And as you explained, then the picture is taken, it comes back down, and the image is
Correct.
returned to the students, but it's available for anybody
Yes,
to see.
the students actually indirectly tell that camera when to take a picture. So that's the neat thing about it is it's not a direct push a button on the ground and it tells the camera to take a picture, but it's the only payload that I know of right now that allows the students to control the payload. It's not a byproduct of another researcher's efforts.
I asked you to bring us a couple of pictures because the next question is what do these kids want to take pictures of? And you provided us with a couple of images. This one I've wanted to show first because most of us can identify what this is.
Obviously, this is Massachusetts, the Cape Cod area. Um, in this picture, it needs to be rotated. It's just kind of a rectilinear location. The north is actually pointing down to the lower right
Hmm.
corner. You can see different forms of erosion, which is the contest that's coming up. The landforms are there. You can also see the uh, transportation routes and the cities and so forth that are in there. Now, this was taken with the 50 millimeter lens, and that image is about 100 by 200 miles length and width. Um, the detail is not so great, but it's nice in the respect that you can actually see major landforms, the urbanization. You can see when things start are being affected. You can see how the soil and so forth actually wash out into the ocean. So it's a really nice picture of a larger area.
The next one is a little more detailed to it. This was, I think, a 180 millimeter lens,
This is
right?
a 180 millimeter lens. Yeah, this image is about 60 by 80 miles. And you can actually see Waukegan in the urban areas. You can see the more detailed, you can literally see city blocks in this one. Uh, the When we are working through the Node 2 window, it is not as optically clear as the U.S. lab window. Those pictures that we get through the U.S. laboratory window are absolutely stunning. The quality and the crispness of the features that come through are just amazing. Again, in this one, as you get closer in detail, you can see more the transportation routes. You can see how the folks line up the streets
Hmm.
and make the city blocks and things like that. You can also see under the water, which unlike the radar on STS 99
Hmm.
gets to the radar and it turns black. We can see underwater. So you can see uh, the beach and how that tapers off into the deeper water in Lake Michigan.
We have one more picture that we can show you where this is a different kind of composition.
Yes, yeah. This is actually in Genoa, Torino, Italy, and you can see the mountainous forms. You can go from the high arid uh, land areas. The closer you get to the ocean, you can actually see the forestation start in darker green areas. And then typically when you have mountains, you will actually see clouds form because of the disturbance in the air that's caused by the mountains. So it points that out there also. It's actually a really neat picture, kind of hidden under the clouds.
Hmm.
You can see some of the more developed areas, and it's also, you can see the students at UCSD kind of traced in the border between France and Italy. So yeah, it's a really neat picture. We have several. We've got over 60,000 images on the ground, I believe, that are available open source to anybody to access through the website that we've got for EarthKAM.
I mentioned earlier, too, that there's a special event going on for the mission this week, the Erosion Challenge.
Yes, because it's Earth Day, Earth Week. The team out at UCSD put together a contest for the participants in EarthKAM to capture an image of an area with some type of erosion. And along with that, they're to come up with a 250-word write-up describing the features and characteristics of their picture, and submit that to UCSD. And then it will be judged with a winner selected on May 10th. And the winner will actually get to teleconference with an astronaut. Do Q&A. For the rest of the participants, it will also be a webcast so they can follow along with the teleconference, and everybody benefits. So yeah, it's kind of neat.
Over 400 schools this week.
Correct, yeah, 411 and over 29,000 students actively engaged this week right now.
And later on this week, we intend to have another feature that will tell you more about some of the students and that are involved in this program. Brian,
Yes.
Appreciate the time and a look at the pictures. Enjoyed it.
Thank you very much. Yeah.
Brian Oy is the payload developer for the EarthKAM investigation on the International Space Station.